Okay, share with me. I want to start off with thinking about magnets. Anyone have played or used a magnet before? Can you put your hand? Who didn't? Crystal, about you?
Huh? No.
Who didn't? Okay. So you know, in a magnet, you must have two poles. Which two poles? North and south. Very good. And what are the properties of this pole? Sorry? Opposites would attract and the same pole would repel. Very good. This is similar to what? Electron or electric charge. Very good. Because that's what we learned before previously. That positive and positive charges, they repel. Positive and negative charges, they attract. So similarly, here you will also put a like pole attract and a like pole, repel. Like pole, repel, a like pole, attract. And what the most fascinating is scientists find out the property of this, and they find out very likely our world is quite symmetrical. And that's what intrigued the scientists to look deeper into different other things. For example, the gravity, whether there is something that is symmetrical to gravity. So far we could not find out. Think about that. Gravity, for example, this is the Earth. And gravity, if I ask you to draw the field line, if you remember, do you remember field line? In electric charge, for example, negative charge, how do you draw the field line? Radiate out, right, or in. And you would say the direction is towards or away from negative. Or maybe I should say positive to negative or negative to positive. Very good, positive to negative, right? So I should draw inward or outward? Inward, very good. That's what you learned in the previous lesson, right? Similarly, if you are asked to draw the magnetic field, these are called electric field, if you recall the name. If you are asked to draw magnetic field, actually you learn it in year 6 as well. Alright, north and south, you draw some kind of pattern. What are these patterns standing for actually? What's the meaning of this?
How people, if there's something in that field, how it will move?
Very close. People said if something is inside the field, then how it will move, right? What is something? For this example, it can be anything.
Symmetrical version.
What will experience a force in this situation? Not anything. Sorry? It could be a proton. It could be what? Electron. So in general, that means what? Positive and negative charges. That means charged particle. Anything with charge. For example, if you got a balloon with charge, they will be attracted or repelled as well. Right? So this is the field, how we define the field, where it will give, for electric field, it will give any charged object to move. Right? When you move something, before they were not moving, and now it's moving, then you must need something. You need what? You need a force. Very good. The charged object would experience a force. Very good. And that's the direction we define from positive to negative. More about that definition itself. You can't argue, hey, why can't it be opposite? It's more like tradition. Similar to the magnets, is from what pole to what pole, if you recall? Year 6. North to south. Very good. So north to south, you would like to put here. Does anyone remember how to draw the magnetic field, the field line, from year 6? Sabrina, can you draw it here? Can you guys try to copy down? I mean, not copy. Just draw a magnet like this one, and try to draw yourself how the field line should look like. Try on your notes. Do you guys agree with this? North to south? Yeah? So I think this is a very good example that you can see this is how it goes. So if you put something that is magnetic, guys, if you put something that is magnetic, that's the direction of force it will experience. That means if you get closer to this, you can see the density is what? Higher or lower? Is higher, is greater density, right? And that means what? More attractive or more repulsive, right? And that is to say the force is greater when you're closer to this. Similar to the previous idea that when you get close to the electron charge, it will be greater force. Repel or attract depending on positive or negative. Here is similar as well. And I could check north to south. Do you agree with this picture? Completely? Yes, I think there is a quite common mistake that you overlook a little bit. I sometimes make this mistake too. Where? Very good. These three to south, right? To south. So it should point towards south, like this. And that will make a perfect diagram, like that. Do you still remember how do we illustrate it? You actually have seen it in year 6. How do we illustrate this? Because remember, field is something that we can't see. Gravitational field on the Earth, how does it look like? It should also radiate. And where should it point to, do you think? Inward or outward? Inward. Why is it inward? Very good. Because for gravitational field, it pulls something towards the ground, towards the Earth itself. And what is something this time? Anything with, previously it was anything with charge. This one is anything that is magnetic. For gravitational field, it will be anything with mass. Very good. Any kind of mass, including everyone here, towards the ground, towards the Earth. So that's why we will draw towards the Earth. Does it make sense to you? So the direction shows you the force where it will pull you, it will add the force on you. Similar here. But the thing is, back to this question, how do we illustrate? How can you see this in the experiment or in the laboratory?
Testing different locations.
Testing different locations, good. What do you use to test? You have seen it in year 6. You can use pounder. What kind of pounder? Iron, very good. We use something called iron fillet. I'll show you in a second to see this pattern. Other than that, what can you use? You can use other than iron, you can use cobalt, because cobalt is also magnetic. What's the other? Nickel. Very good. So basically, these three serve the purpose that if you try to get these powder or filling on this, you will see this pattern as well. Other than that, there is something that can show you direction. The powder, they can't. They have no direction. They're just small pieces.
Compass.
Very good. You can use compass to show you the direction of the magnet as well. So if I try to draw I think these are okay, right? These pages are okay. So if you're asked to think about this before I show you the actual result, I want you to guess. If I got a magnet that have north and south pole, of course, if I put compass on it, how would the direction point to? If I ask you if I define the direction of the compass as in, say this is the Earth, I can just use this. This is the North Pole. Let's say, this is North Pole. And if you use a compass, there must be a needle right inside. And let's say if I stand here, that's the compass where it pointing to the north, of course. Yeah, this is north, not orange. This is north pole. Compass pointing to north. How would that look like if you got a magnet? I will give you a magnet, of course. If I put the compass near it, guess, just guess, how it will look like. Can you draw it on your somewhere on your books as well? Yeah. Just guess. Draw it on your notes. You can use pencil to draw the direction if you're afraid. Anyone would like to try? Just guess. Heidi, can you try? Just guess. My hint is, think about the field line just now. Sabrina drew the field line. On the circle. Now this is a compass, right? So those are compass. Straight. The needle is straight. Yeah. Okay. Good. Okay, great. Have a look of this picture. Do you all agree?
Oh yeah.
Tracy, what do you think? You want to change anything? Can you come out and use this color and change? Okay, just draw it nearby, can you? Just try. Just draw it nearby, yeah, will be good. Yeah, up to you, up to you. I don't know which one is correct. Yeah. You don't need to erase draws like that. Okay, the draws next to it.
No, I think the nose is like that. Yeah, like pointing away. Everything is pointing away from us.
B.
No, it's just pointing away.
Just guess. How about that too? If you think it's correct, you can write again. Draw the same thing again. Whatever. You think it's the same? There must be some direction, right? Okay. Any other version? Any other answer? Any? No? Let's make a vote here to see if you agree with which one, because I want to know. Green one. Can you wave your hand if you support the green version?
For sure.
Green version. No. How about you? How about you? Okay, this one. Okay, how about accept this one? Green version, accept this one. Okay, a few of you. How about the orange one? Orange. Okay. So let's have a look. Alright, we'll go there and have a look. And let me do.